P0722 on this 2010 to 2015 Honda Civic with the 1.8 gas engine is a no-signal fault for the automatic transmission output shaft, or countershaft, speed sensor circuit. In plain terms, the PCM may not be seeing the shaft speed signal it needs. The vehicle may have shift complaints, speed-related transmission issues, or the code may show up with little obvious drivability change. The possible fault area is mainly electrical: the sensor circuit, connector condition, sensor power, signal, ground side, or the PCM input. For this code, treat it as an electrical circuit problem, not a mechanical transmission failure. Before testing, save the captured data and any onboard snapshot with the HDS, then start with the basic system checks. Start by verifying the problem before you tear into the circuit. Turn the ignition switch to on Roman 2, clear the DTC with the HDS, then safely raise the vehicle so the front wheels can rotate freely. Block the rear wheels if you are lifting the front, or use a lift, and make sure the vehicle is securely supported. Start the engine, turn VSA off with the VSA OFF button, put the shifter in D, and run the vehicle at speeds over 12 mph, 20 km/h. Watch the A/T data list and compare input shaft, main shaft, speed to output shaft, countershaft, speed. Then slow down and stop the wheels. If the two speeds are about the same, treat it as an intermittent failure and the system is okay at this time. If they are not about the same, the fault is duplicated and you move into circuit testing. With the failure duplicated, check the VCC1 line first. Turn the ignition switch to lock 0. Disconnect the output shaft, countershaft, speed sensor 3P connector, then turn the ignition switch back to on Roman 2. Measure voltage from connector No. 3, the YEL/RED wire to body ground. You are looking for about 5V. If about 5V is there, the VCC1 wire is okay and you continue to the next circuit check. If it is not there, repair an open in the VCC1 wire between the speed sensor and the PCM. Then go to repair verification. Next, leave the ignition on Roman 2 and the sensor 3P connector disconnected and check the NC circuit. Measure voltage from connector No. 2, the BLK/WHT wire to body ground. Again, the question is whether there is about 5V. If about 5V is present, go check the SG1 side. If about 5V is not present, go after the NC wire for a short to ground or open condition. If the NC circuit showed about 5V, turn the ignition switch to lock 0 and check SG1. With the output shaft, countershaft, speed sensor 3P connector still disconnected, check continuity between connector No. 1, the GRN/WHT wire and body ground. If there is continuity, the SG1 wire is okay. Replace the output shaft, countershaft, speed sensor, then verify the repair. If there is no continuity, repair an open in the SG1 wire between the speed sensor and the PCM. Then verify the repair. If the NC circuit did not show about 5V, turn the ignition switch to lock 0. Jump the SCS line with the HDS and disconnect PCM connector B, the 49P connector. With the speed sensor 3P connector disconnected and PCM connector B disconnected, check continuity between connector No. 2, the BLK/WHT wire and body ground. If there is continuity, repair a short to ground in the NC wire between the speed sensor and the PCM. If there is no continuity, the NC wire is not shorted, so repair an open in the NC wire between the speed sensor and the PCM. After either repair, move to verification. For verification, reconnect all connectors, turn the ignition switch to on Roman 2, and clear the DTC with the HDS. Start the engine, turn VSA off, put the shifter in D, and run the vehicle again at speeds over 12 mph, 20 km/h. Compare input shaft, main shaft, speed to output shaft, countershaft, speed in the A/T data list, then slow down and stop the wheels. If the speeds are about the same, troubleshooting is complete. If the speeds are still not about the same after the circuit path has been handled, replace the PCM. The key on P0722 is to prove the no signal complaint first, then stay disciplined. Check the 5-volt feed. Use the NC voltage result to pick the correct branch. Confirm SG1 or NC integrity, and only then verify the repair under the same operating conditions. For more diagnostic training, visit Diagnostics.